Okay, in this video we continue working through some integration examples that require trigonometric substitution. In part 1 we worked through example A. In part 2 we have done B and C. In this video we're going to start with D. Okay, so in D we notice that the quadratic expression has got a plus, so that means according to this guideline we are going to use the tangent substitution. In D we've got x squared dx all divided by 1 plus 4x squared. So let's call this I. However, we have got a similar problem that we had in part C, in that the coefficient of the x squared is not 1 or plus or minus 1. So that means again here we're going to have to factor out the 4. So maybe that's what we're going to start with. So if you factor out 4 here, then we're going to have 1 over 4 into x squared. In fact, before we continue with this, you might have noticed that in D we have got a polynomial divided by another polynomial. So you might be thinking we could use partial fractions here. However, since this is plus here, it means this quadratic is not factorable here, so that approach is wouldn't be fruitful. Okay, so this is now going to be x squared over x squared plus 1 over 4. So now x squared plus 1 over 4 we can write as x squared plus 1/2 squared. That means according to this framework here, our A is going to be 1/2. So we're going to let x be 1/2 tangent theta. X squared is then going to be 1 over 4 tangent squared theta. Dx on the other hand is going to be 1/2 times the derivative of tangent, which is secant squared. So our integral has got, so remember there is that 1 over 4, it's got x squared in the numerator, so there's going to be 1 over 4 tangent squared theta, then dx is 1/2 secant squared theta d theta. In the denominator we've got x squared, which is 1 over 4 tangent squared theta plus 1 over 4. Okay, if we start with the coefficients, we have got 1/2 times 1 over 4 times 1 over 4. So that's going to be 1 over 32. In the numerator we've got tangent squared theta secant squared theta d theta. In the denominator we're going to factor out 1 over 4 here, and so we're going to have tangent squared theta plus 1, and then remember that tangent squared theta plus 1 is secant squared, so the 1 over 4 in the denominator becomes 4 in the numerator. So this is going to be tangent squared secant squared d theta. In the denominator we have got secant squared, so secant squared cancels out, so this is 1 over 16 tangent squared. Again, if you have watched our videos on integrating powers of tangent and secant, then you will remember that we said at this point we write this thing in terms of secant, because we can integrate secant squared. Integral of secant squared is tangent theta. Integral of 1 is theta plus c. So in terms of writing this in terms of x, this is not going to be very much involving in this case, because here we go. From here, we can write from here, we can write tangent theta is equal to 2x. Okay, and then theta is going to be inverse tangent 2x. So that means our solution in terms of x, tangent theta is 2x. And then theta is inverse tangent 2x plus c. Okay, just one moment, there's a slight error here. 4 over 32 is 1 over 8. It's going to be 1 over 8, and that's going to be 1 over 8 there. All right, otherwise that is going to be our final solution for part D. Okay, this point we are going to give you an opportunity to have a go at the 3 remaining problems here. So just integrate each one of them. You can pause the video, have a go at them, and then when you continue the video, then you can compare with our solutions. All right, we're now going to scroll down to our solutions for E, F, and G. We just would like to remind you that if you have got any questions on the material that we're doing here, any particular steps or conceptual questions, you are free to post in the comments section. We would appreciate your input, your feedback, and we are hoping that these are useful and helpful. Do not forget to subscribe to support the channel. Thank you. All right, so in E, again, we have got the issue about the coefficient of the x squared not being unity. So this time we're going to factor out 9. Factor out 9, then the denominator is going to be x squared minus 16 over 9. Then, of course, so this is x squared minus 4 over 3 all squared. So that tells us that our a is 4/3. And so we're going to set x to be 4/3 secant, because the x squared is positive there. So if the x squared is negative, then it is the sign substitution. But the x squared is positive here, so it's a secant. So dx is going to be 4/3 secant tangent. And so we plug in here, we factor out 16 on 9 and the denominator. So this is going to be tangent squared. The constants work out to 1 over 12. We cancel out tangent, and so we're going to have secant over tangent. That simplifies to 1 over sine or cosecant. That is a standard integral. It's the negative of ln cosecant plus cotangent. Then we're going to bring back our transformation formula so that we can rewrite our integral in terms of x. So secant is 3x over 4. That means cosine is 4 over 3x. So the adjacent is 4, the hypotenuse is 3x. By Pythagoras rule, the opposite is going to be square root of 9x squared minus 16. Now I can see that that expression is exactly the same as that as we noted before. We need cosecant and cotangent. Sorry, this should be cotangent. So cosecant is going to be 3x over opposite. Cotangent is going to be 4 over opposite. And then we plug these here. We've got the same denominator, so we can write this as one fraction. However, since 9x squared is 3x minus 4 into 3x plus 4, we can simplify this. It actually simplifies to the square root of 3x plus 4 over 3x minus 4. So using properties of logs, we can bring the power half this side, so this becomes 24. If you take the negative up, then that means we flip these two, and so that's going to be our answer. Incidentally, since this is a rational function and this time the denominator is factorable, we could use partial fractions as well here. So I'm going to show how this works out. So our method 2, we factorize the denominator, we resolve this into partial fractions, we clear the fractions here, so we plug in the two roots, gives us a is 1 over 8 and b is negative 1 over 8. So we take these and plug them in here, so the integral is now going to look like this. Now be careful here, because of the 3, when we integrate, we're going to divide by 3. So instead of 1 over 8 here, we're going to have 1 over 24 for both of them. Combine them, and we've got exactly the same expression as we obtained using trigonometric substitutions. Alright, for f, we have a plus here, so that means the substitution is the tangent one. This is 2 squared, so that means a is 2. So x is going to be 2 tangent theta. We need x squared, we need x cubed as well. Dx is going to be that. And then if you plug in the constants in the numerator, work out to 16. We factor out 4 here. This becomes secant squared. The secant squared cancels out. And so we've got 4 tangent cubed. And then again, from our studies on the integrating powers of tangent and secant, you're going to remember here, we're going to write this as tangent times tangent squared. And the tangent squared we'll write in terms of secant. And this we can integrate by u substitution. This one is a standard integral. So if you let u be tangent here, then du is going to be just this one. And so that's just going to be integral of u du, which is u squared over 2 multiplied by 4 becomes 2u squared. Integral of tan is just ln of magnitude secant. So this is going to look like this. We need this in terms of x. Remember, tangent theta is x on 2 from here. Just bring 2 that side. So that means the opposite is going to be x, the adjacent is 2. That is going to be the hypotenuse. So tangent we already have here. We need secant, so secant is going to be hypotenuse over adjacent. So we plug this here. We sort out the constant, and then the final expression is going to look like that. Okay, and so for the last one, again, coefficient of x squared is not unity, so we're going to have to factor out 25, and then square root 25 is 5. So then inside the brackets, we're just going to have 4 on 25 minus x squared. So that means the a squared is 4 on 25. 4 on 25 is 2 on 5 all squared. So that means our a is going to be 2 on 5. And this is a sign substitution. So x squared is going to be that, and dx is going to be that. We substitute, we factorize 4 on 25 there. So this becomes cosine squared. And so this is going to be cosine squared over sine squared, which is cot squared. Integrating that is similar to integrating tangent squared. We'll write it in terms of cosecant. Then integral of this is minus theta. Integral of this is negative cot. And then since sine theta is 5x over 2, from here, then the opposite of our triangle is going to be 5x. The hypotenuse is 2, so it's going to be 4. Square root 4 minus 25x squared. Again, that has got the same expression as we have in the original integral, so that's a good sign. And so we need cot. Cot is going to be the adjacent over opposite. Theta is just going to be inverse sine 5x on 2. So we plug those in there. We just multiply by the 5, and so that's going to be the final expression. All right, thanks for watching.